the universe either had a beginning or it didn't have a beginning. So that's where we're starting. We're just thinking about it. You agree that those are the only two choices? It either had a beginning, began to exist, or it didn't. Only two choices. How can we determine which one makes more sense? Why should I think that the universe began to exist rather than being eternal? Well, here's two ways of thinking about it. One is from science. The Big Bang cosmology. In a nutshell, it says that sometime in the distant past, the universe came into existence. It didn't always exist. It came into existence. Now there's disagreement about how that happened, or maybe even when that happened. But it's a pretty solid scientific consensus now that our universe actually did have a beginning.
It wasn't that long ago that a lot of people did not accept that.
Right,
So that
and
was
I'll
a
be getting
major,
into that.
Major change.
The other thing that I'll not be spending time on is a philosophical issue about the possibility of an actual infinite. You know, if our universe, if our world actually has always existed, and time is one thing after another, it would be impossible to have gotten to now by adding, one moment after another. That's a little bit too esoteric to deal with right now, so I'm just gonna stick with the easy one, which is the scientific question. Now here's what George was alluding to. The development of this Big Bang cosmology, okay? Aristotle was a representative of someone who thought that the universe always existed, was eternal. If that's the case, you don't need to explain a beginning because there was no beginning. It just has always been. Einstein came along, and one of the implications of his general theory of relativity that I won't try to explain today is that the universe did have a beginning. Okay? And that was a bit disturbing to him and to others. And they tried to find some way around it. There must be some kind of constant that needs to be added to Einstein's formulas in order to account for allow for a non-beginning universe. Then, what science does is it keeps looking and testing. 1929, Edwin Hubble, of the famous Hubble telescope name, he was looking through the Mount Wilson Observatory for several years and making careful measurements. And the bottom line of his conclusions were, as he was looking at these distant galaxies, is that the distant galaxies were all moving away from us at a great rate of speed and from each other. Everything was moving away from each other, as though the universe itself were expanding. Now they could see this through the telescopes and their measurements. How do you come to grips with that? Because the implication is, if everything is expanding, if you run the clock back, everything starts out from a particular point, and this was the idea. And the Big Bang terminology was coined by a man named Frederick Hoyle, who was ridiculing it. He said, "Oh, you're just talking, some Big Bang." He was trying to look for a way around it. He preferred some steady state idea. And there are several models proposed about how can we avoid a beginning of the universe. And I have some listed at the bottom.
About what year?
Say that again?
About what year did he say or write that?
1929.
Okay. Oh, sweet. Okay.
Yeah, 20th century. So this was a big scientific controversy. And little by little, most scientists became convinced that it was true. And there were some satellite measurements that were taken from the COBE satellite that was mapping the background radiation. If such a thing had actually taken place, then we should be able to detect some faint remnants of the radiation emitted from this great cosmic event. And that was actually detected and conformed to the theory, and it was lumpy in just the right way. And suffice it to say that everybody, aside from maybe a few holdouts, believe that the universe that we have existed, came into being, that started at some point. You know, there was a time when all the astronomers thought that everything that we can see, even through telescopes, are all part of our own galaxy. And so it was quite remarkable for them to have powerful enough telescopes to be able to discern that some of those faint objects were actually galaxies in themselves. So now we'll just take that as a conclusion, okay? The universe had a beginning. Well, now we can go to the next step. It was either caused or uncaused. Okay? Only two possibilities. Something is either caused or not caused by anything. Here's where I get to my syllogism. This is our one piece of deductive reasoning that I'll introduce in here. A syllogism is a particular structure of an argument. So here's our first premise. Anything that begins to exist must have been caused. Does that seem reasonable? It seems universal in our experience that if anything comes into existence, that there was a cause for that. It doesn't just happen on its own. There's an exception proposed that I'll get to. The universe began to exist. Therefore, the universe was caused. Okay, now this is a valid argument. If the premises are true, the conclusion, that third sentence, must be true. It's guaranteed to be true if the two premises are true. So we accept that the universe began to exist. Anything that begins to exist seems reasonable, was caused by something. We don't have things bring themselves into existence. The book doesn't write itself. The idea doesn't form without somebody's mind. So let's hold that, because I'm going to get to some objections here in a moment. And just say that, okay, we have good reason to think that the universe was caused. Now, what kind of cause? Well, the cause can either be a personal cause or an impersonal cause. Here's where we get to the person thing. Personal or not personal? Now, you can tell where I'm going with this. I'm going to say it's a person. Why would I do that? Well, here's my reasons. There's two ways that things can be caused. I didn't have. Let's set some things up. Okay, here's one way. Okay, what caused that book to fall over?
The force you exist.
Yeah, it was this tip hitting it, right? Well, what caused this tip to hit it? Well, it was the action of my arm. Well, what caused my arm to go? Well, it was the muscles in my arm, that did that. You see, what I'm doing is I'm talking about causes that are physical. So one physical thing causes another physical event to happen. That physical event causes another physical event. If I had 100 books lined up like dominoes, and this one falls over and it hits the next one, the next one, the next one, that is an example of event, what I'll call event causation. One physical event causes another physical event. It's sort of like a pool table, where somebody hits the pool cue, all of the trajectories of the balls, do they decide where they're going to go? No, because those balls don't decide anything. Where they go is completely determined by the momentum of some other ball that hit it and transfer the momentum to it. Am I getting through on that? Okay, so that's one kind of cause. And in a physical universe, remember naturalism? In a universe where the only thing that you have are physical things, that is the only kind of cause that you have. So everything, every event that we call an event, can be traced back and reduced to a prior physical event. That's why I said that the thoughts that I'm having right now can be, on that view, can be reduced to chemical reactions in my brain. Those chemical reactions can be reduced to other causes that are prior to that, my environment, my upbringing. It gets very complicated if you're actually trying to map it out. But theoretically, if you had a supercomputer that could map the trajectory and momentum of every particle in the universe, it would be possible to predict with certainty what would happen next, everywhere. Okay, that's a physical view of things and a physical event causation. There's one other kind of cause, and that is a decision, a free will decision. Suppose that I am a personal agent, and I can decide to knock over that book or not. I can initiate something. So this is getting back to Bob, this is my definition of a person at the moment, okay, as distinguished from a material event. Is a person can decide. Matter cannot decide. A person can initiate a new sequence of events. Matter cannot initiate a new sequence of events. It can only respond to a prior event. Okay? Those two, got that distinction between them? Okay? So, here's my illustration of a person actually deciding to do something and initiating a new series of events, a new sequence, a new set of dominoes falling. The first domino doesn't fall on its own. It doesn't decide that that's what it's going to do. It has to be acted on by an agent, a personal agent. Now, what about the universe? Well, the universe is physical. It's matter. How about the beginning of the universe? Well, did any of those particles, did the Big Bang decide to do itself? Well, not of its matter, because matter can't decide anything. So this is why it seems to make sense that the cause of that first event, because that's what we're talking about, the very first event, the cause of that had to be personal. That's why we think it makes sense that it's a person. So here's our complete argument from the universe. This is called the Kalam cosmological argument. The universe had a beginning. For scientific reasons, we think that's a good belief. It was caused, and it was caused by a person. Now, this is the first challenge that comes up. Okay, has anybody ever heard? You probably have heard this argument before, a lot of you, and this is the first objection that's raised. Okay, so David, you're nodding your head. What do you think is a good way to think about this challenge? Remember what we said, our syllogism? Only what begins to exist needs a cause. We know the universe began to exist, but the God that we're talking about, this first cause, didn't begin to exist. It's a category mistake. So the beginner that we're talking about is not in the category of things that began to exist. So it doesn't make sense to ask who began or who created God or who created the beginner. It's like asking what happened before time began. You know, that's a nonsense question. Different categories of things. Or what is south of the South Pole? You know, it doesn't make sense to even ask the question. So here's a way to think of that. You know, since nothing brings itself into existence, something must have existed from eternity. For anything to be here at all, something must have existed. We call that being self-existent or necessarily existent, the philosophers say. It wasn't the universe that was self-existent or existed from all eternity. We've established that. So the beginner, the person who caused everything, must have existed from all eternity. A different category of things. Okay, here's another challenge that those of you that like to read the scientific literature probably came to your mind. Stephen Hawking, maybe the smartest person in the world, I don't know, has a movie out. Haven't seen it yet. Looking forward to it. But he wrote a book recently with a co-author called The Grand Design. And one of his quotes from The Grand Design was this: "Our universe popped into existence with no cause out of nothing." Now, why would he say such a thing? Here's why he would say such a thing. He's a theoretical physicist, and there are some strange things that happen at the really, really tiny level of subatomic particles, where the scientists can observe particles popping into existence out of nothing, and with no cause. Okay, that's what they say. So I'm condensing into a big bang here. I'm condensing a whole lot of argument into something very, very surface on that. But what he says is the same thing that we see happening at the subatomic quantum level could happen for an entire universe. And our universe, he says, is the product of a quantum fluctuation, just like what we see at the subatomic level that brought the entire universe into existence out of nothing. He describes it this way, and others have described it in a similar way. If you have an energy field with zero energy, it really can be thought of as the sum of all the negative energy and the positive energy. Just like the sum of 1 and negative 1 is 0. If you separate that 0 into 1 and negative 1, now you've got two things, right? So if you have all the zero state of energy, but then you split it into 1 and negative 1 analogs, now you've got stuff that came out of that energy. And that's actually somewhat of what they're trying to do with these atom smashers, like the Large Hadron Collider over in Europe, trying to get enough energy in pounding against this quantum field in order to bring into existence some of these very obscure particles like the Higgs boson. Sounds pretty impressive. I mean, smartest guy in the world. You know, we got this Higgs boson looking for, and we got these quantum events happening. You know, who am I to contradict him. Well, not so fast.
We have pretty strong evidence that the universe is not eternal in the past, but had an absolute beginning a finite time ago. In 2003, Arvind Borde, Alan Guth, and Alexander Vilenkin were able to prove that any universe which has on average been in a state of cosmic expansion cannot be infinite in the past, but must have a past space-time boundary. What makes their proof so powerful is that it holds regardless of the physical description of the very early universe. Because we don't yet have a quantum theory of gravity, we can't yet provide a physical description of the first split second of the universe. But the Borde-Guth-Vilenkin theorem is independent of any physical description of that moment. Their theorem implies that the quantum vacuum state, which may have characterized the early universe, cannot be eternal in the past, but must have had an absolute beginning. Even if our universe is just a tiny part of a so-called multiverse composed of many universes, their theorem requires that the multiverse itself must have had an absolute beginning. Of course, highly speculative scenarios such as loop quantum gravity models, string models, even closed time-like curves have been proposed to try to avoid this absolute beginning. These models are fraught with problems, but the bottom line is that none of these models, even if true, succeeds in restoring an eternal past. Last spring, at a conference in Cambridge celebrating the 70th birthday of Stephen Hawking, Vilenkin delivered a paper entitled, "Did the Universe Have a Beginning?" which surveyed current cosmology with respect to that question. He argued, and I quote, "None of these scenarios can actually be past eternal." He concluded, "All the evidence we have says that the universe had a beginning."
Now, what I derive from William Lane Craig's discussion there was he's talking about the quantum vacuum. And when a quantum event occurs, like one of these particles popping into existence, it occurs because of a fluctuation in the quantum vacuum. And so what Stephen Hawking is talking about when he says the universe popped into existence out of nothing, the nothing he refers to as not nothing with a capital N. The nothing is a quantum vacuum. Okay, so that's the first thing to think about, that they're kind of equivocal on what they mean by nothing out of this. But if you have a quantum event like a subatomic particle or a universe popping into existence because of how I described it, the 0 becoming 1 and -1, it's because of the separation that occurs in that field, in that quantum field. So, what William Lane Craig is saying, that quantum field, they're postulating always existed and then had some event take place in it. According to the Vilenkin theorem, that's not possible. Now, I don't know how they come to grips with that, because I would say that that quantum field is a physical thing. And how it exists eternally, I don't know. I don't know how they deal with that. I think, I read The Grand Design, and that was not ever really dealt with adequately, I don't think. It's, you just kind of, these things kind of glossed over. So if you ought to ask that question the next time you're in a room with Stephen Hawking.
I forgot to ask it the first time.
Yeah. So this is the first thing to keep in mind. The quantum vacuum is not nothing. When we're talking about nothing, we're talking about nothing. A state of non-being. Nothing. The second thing to keep in mind is, just because we don't know, or maybe it's even impossible to know, the cause for something, like why a particle pops into existence out of the quantum vacuum, it doesn't mean there is no cause. Make sense? Even if it's impossible to know because we can't measure both the location and the velocity of a particle. It's impossible to know why it pops into existence. It doesn't mean that there is no cause. It seems to make sense that on a physical level, that physical events have physical causes. Now, you can say, well, all we can do is calculate probabilities of causes. Well, okay. Same thing happens with large populations of people. We calculate the probability that they'll decide to do something. That's what marketing is all about, and try to influence it. Maybe there's something similar going on at the subatomic level. I don't know. But it seems to make sense to me anyway, in my limited ability to reason, that just because I can't know the reason for something, the cause, doesn't mean there is no cause. And final statement on this, what Hawking's book about the grand design is about is arguing in favor of something called M theory. It's a way of trying to unify all the different forces of gravity, small and weak nuclear force, electromagnetic force, into one explanatory theory. And he thinks it succeeds. It's the best thing. The book doesn't talk about any alternatives, of which there are some. In fact, this is a hotly contested issue among the theoretical physicists. So don't get fooled into thinking just because the smartest man in the world thinks this is a good candidate that there isn't disagreement with his peers. He's also proposing it as a view of reality. You know, this is the way the universe really is if we take the point of view of the mythical God and look at things. But there's a difference between a mathematical model of something and the way the real thing is. Just as an illustration, use of imaginary numbers, the square root of -1, is a very useful tool when you're trying to model something. But they're called imaginary numbers for a reason. And so to say, well, the math works out and it allows us to make predictions that are true doesn't necessarily mean that you've got a correct model of physical reality.